In this video, we're going to talk about how our upper level positive PV anomalies and our low level positive theta anomalies can work together to form cyclones and thus begin the life cycle of our mid-latitude cyclones through this PV lens. And so we're going to begin by looking here at our upper level positive PV anomalies, which we've depicted here in this figure from Jonathan Martin's book, Mid-Latitude Dynamics. In this figure, at time 0, we see an upper level positive PV anomaly that is on, for example, maybe some upper level pressure surface as we are in our XY coordinate system. And so we know from previous videos and our prior knowledge of positive PV anomalies, we know that our positive PV anomalies induce a cyclonic circulation, which is what is indicated here with our arrows. And so as we illustrate here, this idea of cyclonic rotation along this PV surface, and so we can say, for example, that maybe this is a 2 PVU surface that we're looking at here on the 250 hectopascal level. And so the question that remains then is what happens through time, since ultimately we are wanting to know what's going to happen to this upper level positive PV anomaly and how might that then change through time. And so if we consider that the only way we can change our PV distribution as long as our atmosphere is adiabatic and frictionless is through the advection of PV itself. And so from this initial time, if we have a northward moving wind on the east side and a southerly moving wind on the west side, by the time we move to our next time step at time t equals t1, we now have created a situation in which we have advected less than 2 PVU air to the north, inducing this idea of a negative gradient to the north. And overall, the center of our PV anomaly has actually moved to the west. And so this is not considering any upper level flow associated with it, but if our upper level positive PV anomaly were left to its own devices, it is going to want to retrograde. This would be similar to what we would expect for a large-scale upper-level trough in weak flow. And so again, we don't necessarily get a different solution from this lens, but we get a different perspective from this lens. And if we let this go out in perpetuity, we would have induce then a anticyclonic circulation around this negative anomaly, which would then start to induce a positive circulation, and we'd quickly end up with a wave-like pattern. So from any small initial disturbance, even if it is cyclonic or anticyclonic, we would eventually have a wave pattern. And so this is what would be happening in our upper levels, provided no other knowledge about the flow and just relying on our knowledge of the PV circulation. And so it would retrograde if left to its own devices with no other appreciable flow. So now let's go ahead and see, well, what's going on near the surface? Again, looking at another figure here from the Jonathan Martin textbook, we see our depiction of a positive theta anomaly. And so that's what we're depicting here as our positive theta anomaly. And we can recall that basically what we're seeing here is our low pressure center with a warm front and a cold front, essentially in this situation. And so again, from what we learned in a previous video, we know that we induce a cyclonic circulation around our lows, and that our positive theta anomalies act like positive PV anomalies. But due to the different orientation here of our positive theta anomaly compared to our positive PV anomaly aloft, we do not induce any other type of circulation and simply see a progressive pattern where at a future state in time, our positive theta anomaly has just moved downstream. And so the question is, so if this is going on near the surface, how do we then have these competing factors? Our upper level positive PV anomaly, if left to its own devices, wanting to retrograde or move backwards with time, and our surface anomalies wanting to progress with time, how do these then couple together to help produce mid-latitude cyclones when we know the surface and the upper air's circulations end up being related? So let's go ahead and do a thought experiment and work through figure 9.10 from the Martin text. So if we initially have our upper level positive PV anomaly as depicted here in A, we know that this anomaly does not only affect that particular level, but can influence a depth of the atmosphere. And so that's what we see illustrated here with our little dashed arrow near the surface. And so if we have a strong upper level positive PV anomaly, it can induce cyclonic circulation at a lower level. If we do so at time 2, we see that we've now induced a positive theta anomaly, which then induces its own cyclonic circulation near the surface, which, depending on how strong that positive theta anomaly is, influences our upper levels and creates a positive cyclonic vorticity anomaly aloft, inducing cyclonic flow that is not exactly aligned with our upper level positive PV anomaly. This then imposes additional flow on our upper level positive PV anomaly, and through advection, we are able to move that upper level positive PV anomaly downstream against its natural tendency. If we do so and move that positive PV anomaly downstream, we then induce a new cyclonic circulation associated with that positive PV anomaly, which then reinforces a surface positive PV anomaly to create a stronger positive theta anomaly, which then will induce its own circulation and again reinforce some advection of PV aloft, further increasing the strength of this trough. Now we see this little bulge here in our 2 PVU surface, and from there we see basically an amplification of this upper level pattern, which then would be exhibited by a strengthened jet stream. And so what we're essentially seeing here is the coupling between our surface positive theta anomaly and our upper level positive PV anomaly. Here we've seen then from our upper level positive PV anomaly, we have induced and created cyclones, right? Cyclogenesis through this process, which is quite amazing. And not anything different than really what we see from our QG perspective. From the fact that when we induce this scenario, we must have that upshear or westward tilt with height in order for these two to develop in tandem. And so in order to make a cyclone through this PV lens, we need our initial upper level positive PV anomaly to induce our cyclonic circulation near the surface. From inducing that cyclonic flow, that will deform our temperature gradient, creating a positive PV anomaly. And through this consistent phase locking of our upper level and our lower level patterns, we are able to develop into a robust cyclone. Until such a time as we no longer have this westward tilt with height, and that we don't get this mutual amplification to occur, and we might then get into a occlusion process. We'll talk a little bit more about an occlusion process associated with our diabatic processes in a future video. I hope that this has helped explain a little bit about how we can use this positive PV anomaly and looking at upper level maps to determine where we might see some generation of surface cyclones through this lens that may not otherwise be as easy to identify in our QG lens. Thanks for watching.